Assalamualaikum warahmatullahi wabarakatuh. Inshallah, today we'll continue our chapter on gas power cycle, where we're looking at diesel cycle. Okay, what is diesel cycle? Diesel cycle is the ideal cycle for compression ignition engine, also known as compression ignition engine (CI). Okay, only air is compressed during compression stroke, and diesel is injected at the end of compression to produce a constant pressure heat addition. Okay, different from internal combustion engine, ICE internal combustion engine, where we compress air and the fuel at the same time. But for diesel engine, we compress only air after the end of compression. Only then we injected the diesel. Okay. Maksudnya untuk diesel engine, kita compress air dahulu. Dah habis compression untuk air, baru kita inject diesel. Okay, can be designed to operate at much higher compression ratio than SI engine. SI ni spark engine lah. Okay, spark engine. Okay, typical between 12 to 24 due to absence of auto ignition. Okay, kita compress ni dengan higher pressure, dengan pressure yang tinggi lah, sebab kita tak ada spark kat sini. Tak ada spark, dia tak ada kat sini. Kalau tengok dia punya design, we have a cylinder, cylinder punya casing, okay, cylinder punya casing, and then we have fuel injector. Okay, the ignition datang daripada compression dia. Okay, ignition datang daripada compression dia. Sebab tu dia compress dengan ratio sangat tinggi between 12 to 24. Okay, alright, so this is the PV diagram and the TS diagram for the diesel engine. If you can see, ada different kat sini. Okay, for PV diagram, we can see we have two here. We have one constant pressure and one constant volume. Different from internal combustion engine. Then ICE, kita ada dua-dua constant volume process. Kita ada dua constant process. But this one we have one constant pressure process and one constant volume process. But we have two lah, isentropic process too. So the same as ICE. So this engine have 4 steps. Point 1, process 1, process 2, 3 and 4. Okay, the heat addition come from the process 2 to 3. Heat rejection come from 4 to 1 lah. Okay, alright. So this is the TS diagram. So in TS diagram still the same. We have two isentropic process C. So we have two isentropic process. So two constant lah. Entropy kat sini from 1 to 2 and 3 to 4 is constant. Okay, heat addition come from the pressure constant. Heat rejection come from the volume constant. Okay, the compression ratio. Compression ratio is compression of 1 to 2. Volume 1 to 2. Kita nak compress the volume 1 to 2 is can be written as RV equal to V1 over V2. Okay, cut off ratio. Okay, cut off ratio apa ni? Ratio between this volume ni. 2 dengan 3 dengan 2. Okay, boleh dikatakan juga cut off ni adalah the ratio of the volume of after we inject the diesel divided by the volume before we inject the diesel. Okay, RC we can be written as RC equal to V3 over V2. Okay, kat sini lah berlaku dia punya cut off ratio. Compression ratio kat sini dari sini. Okay. Alright, so what is the process for this diesel engine? Okay, we have the same process like ICE. This engine we have isentropic compression from 1 to 2. We have constant pressure heat addition from 2 to 3. We have isentropic expansion from 3 to 4, and we have a constant volume heat rejection from 4 to 1. Okay, so bila awak lukis dia punya PV diagram untuk dia macam ni. Dia ada satu constant pressure and one constant volume and two isentropic punya process. Kalau TS diagram dia bentuk dia macam ni lah. We have two constant entropy punya ni lah. Okay, constant entropy 1 to 2, 3 to 4. Alright, so what is the equation that we can use? Related equation yang useful lah untuk diesel engine ni. Okay, in process 1 to 2, since it is an isentropic process, so we can write the equation as P1 over P2 equal to V2 over V1 powered by K. K K ni adalah ratio of heat ratio heat. Okay, equal to T1 over T2 powered by K over K minus 1 Okay, awak tahu CP over CV ni K ni. Okay, constant pressure addition can be written as Q in equal to MCP T3 minus T2. Okay, CP kat sini sebab apa pakai CP? Because constant pressure. Okay, pakai CP, constant pressure. Kenapa mesti pakai CP T3 over T2 ni? Sebab kita deal dengan gas. Okay, untuk the steam engine kita consider gas consider the gas, so pakai gas equation Okay, 3 to 4 central expansion is 4 V4 over V3 equal to V3 over V4 powered by K equal to T4 over T3 powered by K over K minus 1. Okay, ini tak jawab isentropic dengan compression isentropic expansion ni lebih kurang dengan ICE lah. Okay, heat constant volume heat rejection. Okay, kat sini pun sama dengan ICE juga. Q out equal to MCV T4 over T1 CV CV constant volume. Okay, constant volume. Sebab apa? Constant volume process heat rejection. Okay, so this is the related equation yang kita boleh guna untuk selesaikan masalah berkenaan diesel cycle lah. Tak ada apa lah. Okay. Alright, so the thermal efficiency can be written as eta TH equal to 1 minus RCK minus 1. Okay, RC ni adalah RC ni adalah cut off ratio. Okay, cut off ratio power by K minus 1 over K. K ni adalah ratio of specific heat ratio of specific heat in bracket RC cut off ratio minus 1 to bracket RV is in yang tukar pula RV ni adalah compression ratio compression ratio K minus 1. So, kalau rasa confused boleh rujuk pada yang nota sebelum ni lah. Okay, the advantage of this engine, high thermal efficiency. Okay, high thermal efficiency, lower fuel cost, more suitable for application with large amount of power lah. Okay, seperti saya guna untuk bus, lori, truck, lokomotif, ship, MJC, power generation set. Okay, this ni lah dia punya application dia. Okay. Alright, so that's all for this cycle. So for your exercise, for your homework, please do this question, exercise 6.2. March. This is a fun question from March 2005. Okay, apa dia kata kat sini? An ideal diesel cycle has a compression ratio. Okay, compression ratio kat sini. So it means for RV 17 and cut off ratio. Cut off ratio ni adalah RC 1.3 at the beginning of the compression process. Okay, at the beginning of the process, the temperature and the pressure of the air are 7. Okay, at the beginning dia kata T1 ni, kita gunakan T1, the pressure and the process 37 degree Celsius, so tukar kepada Kelvin and 100 kilopascal. Okay, ini 100 pascal dia punya pressure at T1 dia. Respectively, if the mass of air is 0.1 kg, show all the process on PV diagram. Okay, so all the process on PV diagram. So lukis PV diagram lah. Okay, PV diagram yang mana? Is our PV diagram lah. Okay, lukis yang ini PV diagram. Okay. Okay, alright. Okay, then question 1. The temperature in degree, pressure capacity at the end of each process. Okay, buat sebelum sama macam ni, sama macam sebelum ni. So at T1 awak akan cari dia punya temperature berapa, P1 temperature berapa, T2, okay, T3, T4, P2, P3, P4. Macam mana nak cari? Just use this equation lah, related equation yang ada ni untuk carilah. Okay. Alright, okay, the heat addition during the constant pressure process. Okay, addition pun sama. We have this equation, so just use this equation. But you need to know the temperature lah dulu. Okay, awak kena cari temperature dia dulu. Okay, and then the word net output. Okay, word net output. Word net sama dengan apa? Okay, word net. Kita tengok rujukan nota sebelum ni. Kita ada tulis pasal word net. Okay, word net sama dengan Q apa minus Q apa. Okay. Okay, the thermal efficiency. Thermal efficiency adalah yang inilah. Okay, thermal efficiency. Okay, and then the mean effective MEP. Okay, MEP pun ada dalam nota sebelum ni. Cuba tengok nota yang sebelum ni lah. Okay, MEP dia. Alright, itu saja untuk hari ini. Assalamualaikum warahmatullahi wabarakatuh.